All right, ready for a deep dive. We're looking at this paper from BitEnergy AI, and man, it could be huge for AI.
Yeah, it really caught my eye, too. Addition is all you need for energy-efficient language models.
Yeah.
It's like a bold statement.
No kidding. But before we go too deep, can you remind us why AI using so much energy is such a big deal these days?
Well, imagine like a whole country. How much power it uses, that's how much some AI models need these days.
Yeah.
Massive electricity bills, not great for the environment.
Yeah, not exactly eco-friendly. So this is trying to fix that.
Exactly. See, AI, it's all about crunching numbers.
Right.
And usually that means tons of multiplication with these things called floating point numbers. Basically, decimals for computers.
Okay, right. I remember that from somewhere. But why is that bad? Why does multiplying decimals take so much energy?
It's kind of wild, actually. Multiplying those floating point numbers, way more energy than just adding whole numbers. Like up to 37 times more.
37 times. Seriously. Okay, so what's the solution? Are we going back to like an abacus or something?
Not quite. These researchers, they came up with this cool algorithm, linear complexity multiplication, or they shorten it to Mul. And get this, it swaps out a bunch of that multiplication with, you guessed it, addition.
Now that's clever, but how does that even work? Are they changing how math works?
Not really changing it, just like optimizing it. They found a way to use addition, but it gets super close to the same result as multiplying those decimals.
So addition that pretends to be multiplication but uses less energy, fascinating. But the real question is, does it actually work? Like in the real world, not just on paper.
That's the million-dollar question, right? And they
Mhm.
tested it on a bunch of stuff, language tasks, visual stuff, even, get this, grade school math problem.
Wait, grade school math. Seriously, tell me more.
So they use this data set, GSM-8K. It's got thousands of those word problems you see in school. And yeah, they seem simple, but they make AI really think logically.
Okay, interesting. So how did Meal do against those word problems?
It aced them. And here's the kicker. Sometimes it actually did better than other methods out there, and using less energy all the while.
No way. So it's not just as good, it's better. This is blowing my mind. So in plain English, what does this all mean?
It means we may have been overlooking something big. The whole time we thought AI needed to be super complex, but maybe simpler math, like addition, can be just as powerful.
Mind-blowing. So instead of cramming more power into AI, it's like we found this shortcut.
Yeah, exactly. We were trying to make a car faster by just giving it a bigger engine. This paper's saying maybe we can make the car itself better, more aerodynamic. That's what this could be for AI.
I get it. I get it. This is huge. But let's not get too ahead of ourselves. Are there any downsides? Like things they still need to figure out?
Right, of course.
Yeah.
So this paper mostly focused on one part of AI models called attention mechanisms. It's like the brains of the operation, how it focuses on what's important.
So they haven't totally reinvented AI just yet, just this one part.
Yeah, they did a few tests on replacing all the multiplication with Himmel, but they need to do a lot more research. It's like, we know this new fuel works in a car, but will it work in a plane? We don't know yet.
Great analogy. So while this meal shows promise, we got to see how it does in other AI situations, right?
Absolutely.
Yeah.
But man, the potential here is huge. If they can perfect this mole and everyone starts using it, we're talking way more sustainable AI in the future.
And sustainable means saving the planet and saving money on those crazy electricity bills, right?
Exactly. Good for the environment, good for our wallets.
Win-win.
Right.
Totally. Now, something else they mentioned, this FP8 thing, what's that all about?
Good eye. So FP8, it means 8-bit floating point numbers. Basically, it's a way to store numbers in a computer, but only using 8 bits of data.
Okay, smaller numbers, got it. But how does that save energy?
Smaller numbers are just easier for computers to handle, right? Like
Yeah.
adding up pocket change versus doing your taxes, which takes more energy.
Taxes, for sure. So
Mhm.
smaller numbers, faster calculations, less energy.
You got it. And in AI, we're talking trillions of calculations every second. So even tiny improvements add up big time.
Makes sense. So how does AMOL compare to these FP8 numbers? Who wins the energy saving contest?
Ooh, good question. That's where it gets interesting. They really dug into the nitty-gritty, like precision and how complex the calculations are. And they found that a mole, especially when you use 3 or 4 bits for the mantissa.
Hold up, mentees. Time for a quick explanation.
Right, sorry. Imagine a number with a decimal. The mantissa is the part with the important digits. Like in 1.23 by 104, the mantissa is 1.23.
Okay, I get it. So they found that using a smaller mantissa with OML uses less power than FP8 multiplication.
And it's actually more accurate, too.
Wait, more accurate, more efficient? That sounds impossible.
That's what makes it so cool. They ran tests on a bunch of well-known language models, and it's consistent. We'll beat those 8-bit methods every time, even sometimes matching the 16-bit ones, which use way more energy.
So they found a way to make AI better and more efficient. This is incredible. It's like having your cake and eating it, too.
Totally. It's like a breakthrough. We might be seeing a totally new era for AI, where it's not about brute force, but about being smart and efficient.
This is like finding a secret shortcut in the world of AI, a whole new path.
Exactly. And like any good shortcut, it could change everything.
So what happens now? How do we get this Amul out of the lab and into the real world?
Well, first things first, they got to get this Moo thing actually built into computer hardware.
Uh,
Right now, it's all just simulations like blueprints.
So we have the design for a super efficient engine, but no car to put it in yet.
Exactly. If they can make computer chips specifically for this addition-based stuff, it could be even more efficient.
Like building a race car with a custom engine instead of just a regular one, the performance boost would be insane. So hardware's a big one. What else needs to happen with this Momo?
They also want to see how it does in other parts of AI, not just those attention mechanisms we talked about.
Right, because AI is used for so much more than just that. It's like we know this new fuel works in a car, but what about planes, trains, spaceships, the whole shebang?
Yeah, exactly. They got to push the limits, see if this addition-powered revolution can really go the distance.
I'm ready for it. Okay, so new hardware, new applications. Anything else we should watch out for? Like, how do we know if this is really changing things?
Keep your eyes peeled for news about AI actually using less energy. That's the real test, right?
So headlines like AI now powered by a single AA battery. That's what we're hoping for.
Maybe not that traumatic, but you get the idea. If those big, power-hungry AI systems start using way less energy, that's a real game changer.
For sure. Okay, circling back to something you said earlier about this research challenging a fundamental assumption about AI. What did you mean by that?
For the longest time, everyone thought bigger was better with AI. More computing power, more complex algorithms, more data. But this research, it's like, hold on, maybe there's a smarter way.
Instead of just adding more horsepower, it's about using the horsepower we have more efficiently.
Exactly. And that changes everything. Suddenly, we can have AI that's not just more sustainable, but also more accessible and even more powerful.
That's future I can get behind. You mentioned accessibility. How would this make AI more accessible?
Think about it. If AI suddenly costs way less to run because it uses less energy, then more people can use it. Smaller companies, researchers, even just regular folks could develop their own AI.
So it wouldn't just be big companies with tons of money and computers controlling AI. It'd be more democratic.
Exactly. And that's exciting because it means more innovation, more people with cool ideas who can actually use AI to make them happen.
I can already see the possibilities. This isn't just about saving energy and money. It's about making AI more inclusive, more open to everyone.
100%. And that's what makes this research so compelling. It's not just a small improvement, it's a potential revolution.
I love that. It's not tweaking the system, it's rethinking the whole darn thing. Now back to EML and those smaller FP8 numbers. You said EML, especially with a certain mantissa size, could be even better. Can you unpack that a bit?
Sure. The mantissa, remember, it's the part of a number with the actual digits, the important stuff.
Mm-hmm.
And they found that using a 3-bit or 4-bit mantissa with Mul was like a sweet spot.
The perfect balance between simplicity and getting the job done.
Yeah. Fewer bits means faster, more efficient calculations,
Mm-hmm.
but they still got accurate results, sometimes even better than before.
Like they found a way to compress information without losing anything important.
Exactly. It's about being clever with how we represent and process information. That's what makes it so innovative.
This is all fascinating, but I'll admit, I'm still trying to wrap my head around how addition can do what multiplication does in AI. How does a mole actually work?
It's a bit complicated, but basically they use a special kind of addition. And they combine that with some really clever ways of representing the data and optimizing the algorithms.
So it's not just addition like we learned in school, but something way more advanced, specifically designed for AI.
Exactly. It takes a lot of expertise in math and computer science to come up with something like this. It's really impressive.
Mind-blowing. It just shows what can happen when you think outside the box and challenge those old assumptions.
For sure. This research is a perfect example of that. Sometimes the best solutions come from rethinking the basics, not just making things bigger.
So what's next for Mole? What are the researchers hoping to do now?
Well, they're really focused on getting this ML actually built into hardware.
Right, because like you were saying, right now it's all just simulations.
Exactly. If they can make chips designed specifically for this, it could be a game changer.
Yeah, like a custom-built engine. That'd be amazing. So hardware's huge. What else is on the horizon for Mul?
They're also really interested in seeing how Mul performs in other areas of AI. We've talked a lot about attention mechanisms.
Right. But AI is used for way more than that.
Exactly. They need to see how it performs in all sorts of AI models.
See if this addition-powered revolution can take over the world. This is seriously exciting stuff. It feels like we're on the verge of a whole new era for AI. But with all this potential, are there any downsides? Anything we should be cautious about?
That's a really good question. And honestly, yeah, there are always challenges. One of the biggest is just, getting people on board.
Because everyone's so used to thinking bigger is always better.
Right. It's hard to change that mindset.
Right.
But the potential benefits here, I mean, lower costs, less energy consumption, more people being able to use AI, it's hard to ignore that.
No, absolutely. So as we wrap up here, any final thoughts? What's the big takeaway from all of this?
I think the biggest takeaway is don't be afraid to challenge assumptions. For years, we thought the only way to make AI better was to throw more power at it, more complexity. But this research shows us that sometimes the best solution is actually simpler, more elegant.
It's like that saying, the simplest explanation is usually the right one.
Exactly. And this could be huge for AI,
Hmm.
making it more sustainable, more accessible, and ultimately more powerful. And to think, it all comes down to addition.
It just goes to show sometimes the most fundamental concepts can lead to the biggest breakthroughs. Well, this has been an incredible deep dive. Absolutely fascinating. Thanks for taking us through it.
My pleasure. It's been fun.
And there you have it, folks. Who knew that something as simple as addition could hold the key to the future of AI? Until next time, keep those minds curious, and we'll catch you on the flip side for another deep dive.